Welcome to This Explainer. Today, we're going to completely dismantle an idea that society has basically taken for granted for centuries. We love to believe that we're the conscious authors of all our actions, right? That our choices are entirely voluntary. But what if free will, at least when it comes to some of our most fundamental behaviors, is actually kind of an illusion? Well, let's dive into this by looking at one of the most misunderstood conditions in modern medicine, and that's severe obesity. We're going to explore some genuinely compelling scientific evidence that shows how human behavior, specifically things like our appetite, impulsivity, and caloric intake, is heavily constrained and maybe even predetermined by our genetics, brain chemistry, and neural circuits long before we ever have a conscious thought. For decades, we've been fed this prevailing societal narrative that weight management is simply a matter of calories in, calories out. It's an idea completely built around personal responsibility, meaning success or failure in managing your weight is always just a matter of discipline and sheer willpower. But honestly, ask yourself this. Why is it that two people exposed to the exact same environment with access to the exact same food can behave so incredibly differently? Research is increasingly showing us that a lot of our decisions actually originate deep in the brain before we even consciously realize we're making them. When someone repeatedly goes back to the fridge, society calls it a lack of self-control. But as we're about to see, it might actually be a profound biological limitation. They aren't deciding to fail, their biology is literally making the decision for them.
To really grasp this, we need to talk about monogenic obesity. This is a form of early-onset severe obesity caused by a mutation in a single gene. Now, just defining this condition immediately shifts our perspective away from what's called the hedonic pathway, which is all about reward or pleasure-based eating, and forces us to look straight at the homeostatic pathway. This is the core metabolic pathway controlling your energy intake and expenditure. When a patient has monogenic obesity, their rapid weight gain and insatiable hunger, even as an infant, isn't some behavioral choice. It's a fundamentally broken biological pathway. Their biology is totally overriding any concept of choice.
Now, body weight is obviously influenced by a massive complex web of intersecting factors. We're talking metabolic rate, fat-free mass, physical activity, and your cultural environment. We definitely aren't ignoring those pieces of the puzzle. But to truly understand how our behavior is physically constrained by our biology, we're going to focus entirely on the foundational layer of this whole system, the individual disposition that's governed by underlying genetics and neural pathways. All right, moving into section 1, the normal machine. Let's look at how the brain's hunger wiring actually works when it's functioning properly. We need to venture deep into the brain's ultimate control center for energy balance. This is the arcuate nucleus, located way down in the hypothalamus. Think of this area as your body's master biological thermostat. Right here, we have two opposing neural microcircuits that are in a constant 24/7 battle to control your energy balance. On one side, we have the AGRP and NPY neurons. When these fire, they scream hunger and actively stimulate you to eat. On the flip side, we have POMC neurons. When these guys fire, they signal satiety or fullness, and they dial back your food intake. These neurons react to your body's energy status and take in signals from peripheral hormones to completely dictate your feeding behavior. You don't consciously control these neurons. They control you. So how exactly do these neurons know when to fire? Let's walk through a normal, healthy leptin-melanocortin pathway, step by step. First, a hormone called leptin is secreted right from your white adipose tissue, that's your fat reserves. Think of leptin as a little chemical messenger carrying a status report on your energy reserves. Second, that leptin travels all the way to the brain and binds to the leptin receptor, or LEPR. Third, this binding activates those POMC neurons we just talked about. Fourth, the POMC neurons release signals that trigger the melanocortin 4 receptor, or MC4R. And finally, step 5, this whole cascade successfully suppresses your appetite and actually increases your energy expenditure. Just like that, the urge to eat completely vanishes. So, the absolute crucial point here is that this intricate neural network, the MC4R pathway, is the actual physical mechanism of what we casually refer to as willpower. When these signals flow uninterrupted through your brain, regulating your caloric intake feels effortless simply because your biology is doing all the heavy lifting for you. The brain seamlessly detects the body's energy reserves and just shuts down the motivation to eat. No conscious effort required. Which brings us to section 2, the breakdown. What exactly happens when these crucial satiety signals just break? What happens when this delicate internal thermostat gets physically cut? Well, this is exactly where the illusion of voluntary choice shatters.
Some people inherit genetic mutations that act as biological antagonists, physically disrupting this critical signal. This can happen through mutations in the gene for the leptin receptor, LEPR, or it can happen through mutations in the POMC or MC4R genes. If a child inherits these specific mutations, the biological pathway is quite literally severed, and the result? The brain becomes completely blind to the body's massive energy reserves. Because the brain can't properly detect those satiety signals, the outcome is hyperphagia, which is an intense, absolutely insatiable hunger. The patient continues feeling desperately, physically starving, even after they've consumed more than enough calories.
It is exactly like having a broken thermostat in your house. The thermostat never detects the heat, so the furnace, it just never turns off. And obviously, the furnace isn't lacking discipline, right? It's experiencing a mechanical failure. In these patients, insatiable hunger is a mechanical failure of the body's communication system. It is not a moral failing or some lack of personal motivation. They are trapped in a biological state of perceived starvation, entirely stripped of their choice in the matter.
Okay, let's look at Section 3, Precision Medicine for Obesity. It's time to talk about the targeted fix.
Fortunately for all of us, modern science is moving past the blame game and stepping into an incredible new clinical reality. If we know that a behavior is being driven by a broken biological wire, can we use targeted therapies to reconnect it? Absolutely. By mapping a patient's physical symptoms, their phenotype, straight to their exact genetic code, doctors can pinpoint exactly where the pathway is broken. If they find a mutation in the MC4R pathway, they don't just tell the patient to try harder and prescribe more willpower. They prescribe precision pharmacotherapy tailored to bypass that specific genetic roadblock. Enter an incredible drug called setmelanotide. Setmelanotide is an MC4R agonist. And what does that actually mean? It means it acts directly at the very end of the line, the melanocortin-4 receptor, to artificially trigger the brain's satiety response. Even if the leptin receptors or POMC neurons upstream are completely broken by genetic mutations, setmelanotide basically steps in, downstream, mimics the missing chemical signal, and finally tells the brain, hey, you are full.
The data from the Phase 3 clinical trials is nothing short of breathtaking. When you pharmacologically restore this missing fullness signal, the behavioral change is automatic and profound. Over roughly 1 year of treatment, patients with POMC deficiency saw a staggering mean weight loss of over 25%, with 80% of those patients losing at least 10% of their body weight. In patients with LEPR deficiency, the mean weight loss was 12.5%, with 45% reaching that 10% weight loss milestone. This is massive, totally life-altering weight loss, achieved simply by fixing a broken chemical wire. Now, you might be looking at this and wondering, hey, why did the drug work twice as well for POMC deficiency compared to leptin receptor deficiency? Well, the authors of the study posited a really fascinating reason that highlights just how staggeringly complex our neuronal wiring is. In POMC obesity, setmelanotide is able to almost completely restore that missing downstream signaling. However, the leptin receptor is way more complex. LEPR isn't just expressed on POMC satiety neurons, it's also expressed on those AGRP hunger-inducing neurons we talked about earlier. Because the breakdown is more intricately woven into both sides of the energy balance scale, bypassing it only partially restores the homeostatic signaling. It's a really delicate balance. In terms of safety, the trials showed setmelanotide was actually very well tolerated. There were no treatment-emergent fatal adverse events or cardiovascular issues linked to the drug. Some mild nausea and injection site reactions were reported, which is pretty standard. But here is an absolutely fascinating side effect. Skin hyperpigmentation was seen in 100% of the POMC patients. Why on earth would that happen? Because the melanocortin pathway doesn't just regulate appetite in the brain. Related receptors in a skin actually stimulate melanin production. Activating this pathway artificially to cure hunger simultaneously darkens the skin, proving just how incredibly interconnected our biological systems really are. As perfectly stated in the source literature, we are moving toward a wiring diagram understanding of appetite control. We're no longer forced to look at human behavior purely through a philosophical or moral lens. We are literally entering an era of mapping the brain's exact circuitry. We're tracing the very physical, chemical roots of motivation, reward, and decision-making. Which leaves us with a pretty profound question to ponder as we wrap up today. If a behavior as powerful and all-consuming as severe obesity can be essentially switched off by simply reconnecting a broken biological wire, how is precision genetics going to reshape our broader view of human behavior entirely? If our biology dictates our choices long before we are consciously aware of them, perhaps it's time we finally trade our societal judgments for scientific understanding. Perhaps true compassion actually begins when we recognize the very real biological constraints placed on our perceived free will. Thanks so much for joining me on this explainer. I really hope this changes the way you look at the human machine.